Okay, so I'm Huijie from OpenJournal. So today with our colleague Chenjing, Qingwen, and Li Liang, we will give you a brief introduction of the AgiBot World Challenge at 2023 in the IROS conference. Yeah. So in this introduction, we will not go too deep, but we will just give you the first impression of the challenge. So this is challenging is based on the AGI bot world dataset. The alpha version of the dataset is published at the end of 2024, and we have the full version released in January this year in 2025. The motivation for us to build this dataset is that we want to build a scalable and high quality dataset, because if you see the existing dataset, you can find that most of them, although the size of the dataset is large, like the Open Embodiment X, they are collected from a heterogeneous robot, so we need to deal with problem like cost embodiment when using this dataset. But in this dataset, you can regard that all the data is collected from one single robot. Yeah, so the most important characteristic I think for this data set is that we have a large amount of data. So currently, the version released in January this year, the data set contains over 1 million trajectories covering over 2,000 of tasks. And this is not the final version of the data set, and we will definitely include more data in the future as planned. So in this dataset, we cover 5 types of scenario: the industry, home, supermarket, restaurant, and office. All these scenarios are come from our data. Our vision is that our dataset can become a stepstone toward the future where humanoid robot can be applicable in our everyday life. So in this slide, I just show some statistics of the dataset. The first figure is the data distribution. Now, the home scenario take the majority of the data set is about 40%, and the restaurant and industry have the same amount of 20%, and office and supermarket scenario cover the remaining 20%. And the second figure show the object distribution in this data set. So our data set do not only contain which body, like the book or pen or something, but also it contains some soft object like the food and fabric. So this make make the object diversity in our dataset more. So last figure, I think it is the second important characteristic of the dataset. The time span of our tasks are longer than other datasets. You can see in the figure, the vast majority of data, the time span of the vast majority of the data go over 30 seconds. So this means that we can include more complicated tasks in our dataset. So the scenario in the dataset are more close to our everyday life. So next is about the hardware. At the beginning, I just said that our dataset, you can regard our dataset is collected from one single robot, but in fact, we have over 100 robot in the fraction. And also here, I want to say a big thanks to our cooperator, including the teleoperator and annotator. They do a large amount of job in collecting the data. Yeah. So this slide shows some statistic of the hardware, but I'm not going into detail here. But you can see that our dataset have a large amount of sensor, and also the robot is armed with a desk hand, so we can the robot can conduct some complicated task. Yeah, by the way, this G1 robot is available on the market. So if your lab or your company want to buy one, you can go to the official website to have a look. It will cost about 70 to 80 US dollar, and the shipment of the robot will take about 2 months. Okay, so this is the pipeline of the annotation. So with this large amount of data, we have a mechanism to ensure the data quality of the data set. So at the first step, the tally operator will have a first load of the data right after the collection of the data, and then the data will be uploaded to the cloud, and our annotator on the cloud will have a check on the data quality, and also they will make some annotation. Besides, we have also a feedback mechanism. So we will collect some failure case when collecting the data, and then we will use these cases to retrain our data collector to make them have the ability to collect more high quality data. Yeah, so that's all for the data set. Just go into the challenge part. So I put a text edition 2025 here. We will continue as planned to hold this AgiBot World Challenge every year, no matter in which conference. And also the topic is not fixed. We will see the challenge topic according to the status quo of the community. So in the first edition of the AgiBot World Challenge, we will have two tracks. The first one is manipulation, and the second one is the raw model. The manipulation check will be done on site, but yeah, I will give you more detail later. But yeah, I just want to go to some motivation for us to hold these two topics in this year's challenge. Yeah, so compared to previous and concurrent challenge, our motivation benchmark feature the most comprehensive scenario and task coverage, featuring manipulation with liquid, fabric, and articulated objects. We also require all model to be deployed in our real-world setup and be evaluated on site. On the long run, we are planning to design brand new tasks and also entire desk hands or multi-agent cooperation. Test suite will provide non-comprehensive manipulation tasks, dynamic scenes, and all kinds of objects, as we plan to comprehensively evaluate each policy. Regarding scenario coverage, the robots will be placed at real-world scenes, not in kitchen or in supermarket, not just performing tabletop manipulation in controlled lab environment. And for the world model chat, we expect the model to be truly generalizable and functional. Our test bits entail imperfect rollouts, not only explore demos, video from unseen tasks that is not available for published training data, and the video length is dynamic. So beyond visual quality, we propose a more comprehensive matrix system, also including scenes, motion, and semantic quality to fully evaluate the performance of different role models. Yeah, so here is some logistics of our challenge. So as I said before, the manipulation check will be done on site, and the online frame of this chat is already open. So in this week or next week, we are busy open sourcing the baseline model, the data, and also the simulator. I think the simulator and data in the simulated environment is just right on the way. You can check the link in our Challenger website in the future days. Yes, and at the end of next month, the test server will open. And please note that the evaluation process in the test server will be done in a closed manner. So this means that you need to wrap your model in a Docker. And also, in next month, we will provide some detailed instruction and also a guideline for you to pack your model. So one important thing is that you need to register your team in using the registration form, because the account and the password of the test server in the manipulation chat will be distributed according to the registration information. So you can only get your account to submit your model if you are registered. And also both checks will be end at the beginning of September, and in September we will invite top performing teams in the online phase to come China or come to some factory to test in real robot. And we will guarantee that all the team will have the same amount of time to test the robot. And then the final competition will be conducted in the IROS conference. And for the role model checks, this check only contain online phase, so the timeline is similar, but the test server will open about 3 weeks later than the manipulation check, and also the test server will be called at the same day. So after the submission deadline, we might require you to submit a technical report or related material to help up to validate your result. And the awards announcement will be also done in the IROS conference. Yeah, okay. So here is the price of our challenge. Also a big thanks to our sponsor. The winner of each check will take a prize of $10,000, and the second and the third place will share $5,000 and third $3,000 separately. So as for the channel grant, this is not for the top performing team. For the distribution of the channel grant, we will follow the DEI principles, and we lean to distribute this channel grant toward underrepresented teams or groups from all over the world. Yeah, okay, so on the right side of this page, you can find some QR codes. So the first one is you can learn more about our dataset. This is a block. So for the second one is the registration form. So we have also the link in the website, so you can scan the QR code, or you can just click the link to register. And also the last one is to join the Discord community. And one thing to know that is that please also check your spam. Our official announcement will be sent out using this email. So please check your spam and make sure that you can receive the notification. But also the same announcement will be made in the challenge information channel in the Slack, and also you can use this QR code to enter the Discord channel. And we have also another channel in Discord for you to discuss with us and also with teams from other country. So you can discuss whatever you want. And also for the current for the status code of the challenge, we have received more than 100 registration in the registration form. So you can expect that the challenge will be very competitive. So, and also for the registration form, the submission deadline is September the 1st. And also, if you have already filled the registration form, you can also make modification on that. Okay, I'm just stop here and see if any one of you has some question, and or if not, we will go to some detail of the manipulation and role model check.
So let me introduce the manipulation check of our competition. In this track, participants need to train their own models and control robots to complete tasks, both in simulation environments and the real world. Your model can take sensor images as input, including head view or wrist view, current or past movement, and also the robot's physical state, like its end-effector pose or joint angles, and also description of the task, which are in form of natural language. We'll provide you with data from both real robots and simulations to train your model. Our dataset includes 10 different tasks covering various levels of difficulty, such as handling liquid, articulating objects, moving objects, and operating under height difference, as well as different real-life scenarios, including catering, home, industry, and supermarket environments. Our data format is consistent with AgiBot World. So you'll have all the info you need, like test details, RGB images, camera parameters, and robot states. You can check it by just scanning this QR code, and I also give you a quick look at our data format now. So as you can see, our data directory have 4 subfolders: observations, parameters, proper stats, and task info. I also slice a small part of it here. So in each folder, you can see a number like 327 and 352. So these are task index for 2 different tasks. And in each subfolder, you can also see number like 64A, 642, 648, 649. So these are the episodes index of different episodes. And let's move to the task info folder. So for each task, we've got a JSON file that describes all the episodes under the task. Episodes ID, episode ID 608, 649. And this file also covers the specific task description, task name, pick up items in the supermarket, task 9, and also some sub-goal annotation, start frame, end frame, sub-goal, start frame, end frame, sub-goal. So you can also use the sub-goal annotation to improve your own model training, and maybe in respect of reasoning capability. And in the observation folder for each episode, we've got RGB videos, including head view, and left wrist view, right wrist view. In parameters folder, we provide the camera's intrinsic and extrinsic parameters for each episode. And in the purpose folder, we've got state and action data for each episode in HDF5 format, action state. So you can find end effector pose, position, orientation, and joint angles. And to help you start running quickly, we've also released a baseline model called UniVLA. UniVLA is an open source VLA model with an embodiment agnostic latent planner. And if you want to learn more about UniVLA, you can also scan this QR code or just search in GitHub. To get rolling with our baseline model, you can just search our repo and follow the instruction to set up your environment, install necessary dependencies, download necessary checkpoint, latent action model, visual backbone, pre-train UniVLA. You should also modify the model path and data path in the training config file here. Well, we've also got some 5-gram metric for test completion. Notice that we not just only use success rate as our metric. We broke down each task into sub-goals, and we're averaging the scores across all the sub-goals to get your final test score. Let me give you an example. Say the task where the robot need to make a sandwich includes a step. Pick up a slice of bread and place it on the plate. Pick up a slice of bacon and place it on the bread. Pick up a slice of lettuce and place it on the bacon. And pick up another slice of bread and place it on the lettuce. So the robot's final score will be the average of all the scores for each step. Now let me show you more cases. So in this video, the robot got a score of 1. The robot, you can see that the robot successfully picked the bread and place it on the plate, and pick the bacon, place on the bread, pick the lettuce, pick another bread. So it scores 1 for each step and got a final score of perfect 1. And but in this video, the robot doesn't have any precise positioning capabilities. It failed to pick up the bread and even knock over the bread maker, messing up everything and caused the researcher to intervene. So it scores a 0 on each step. And as a consequence, the final score is also 0. In the last video, the robot struggle to pick the bread, but finally finish it. So we give it a score of 0.5 for this step. Then they place it on the plate. We give it a score of 1, and they pick up the bacon, scoring 1. Place it on the bread, scoring 1. However, it failed to pick up the lettuce and failed to finish all the subsequent steps. So the final score is 0.5, pick up the bread, plus 1, place it on the plate, plus 1, place the bacon on the pick up the bacon, plus 1, place the bacon on the bread, plus 0, and dividing by 8. So the final score is 0.4375. Okay. And if you got any other questions, please feel free to contact our tech leads, Kimen, Pu, or Qingchen, or just drop your question in GitHub issue section. We're quick to respond. And you can also join our Discord community to chat it up with our fellow competitors.
All right, let me introduce the one model track. First, let's clarify the task objective. You will get one initial image from the robot's head camera and a sequence of actions it takes. Your job is to generate a video that starts with that first image and follows all those actions. In our test set, some action sequences are longer, some are shorter, so your generated videos will need to have different lengths too. Then about the data, you can grab it from the competition website or just scan this QR code here. We give you more than 30,000 training samples showing how robots doing stuff in 10 different tasks, in kitchens, restaurants, bathrooms, that kind of thing. You will see all sorts of robots actions like picking things up, putting them down, pushing, pulling, bumping into stuff. Here I can show you how to download the data, and it's already here on the AgiBot World Hugging Face website. You can also enter this site from the competition official website, and we have already split the data into the training set and the validation set, not very large. It's quite easy to download them. We also give you 30 validation samples to test your model locally. That's super important because you only get a few tries on the test server each week. So make sure your code works on this first. The ground truth of the testing dataset is not disclosed to participants. What's special about the test set is it contains both familiar things from the training set and some new environments you haven't seen before. There might even be some unseen interactions there. What we are really looking for are models that can generalize well to these challenging cases. Okay, then about our baseline model. You can find the repo link on the competition website or just scan the QR code on this slide. We are using AgiBot's newest EVAC model as our baseline solution. Let me break it down for you. This is a diffusion-based video generation model. Here's how it handles action sequence. First, it converts the actions into what we call action maps. You can see them in this architecture diagram, and feeds these into the diffusion network for pixel-aligned control. At the same time, it also encodes the actions into vectors and injects them through cross-attention to boost the control effectiveness. EVAC applies chunk-wise autoregressive diffusion strategy during both training and inference, which means it can handle videos of different lengths. If you want all the technical details, check out the EVAC paper. And I can show you the baseline repo here. It's already here. In our baseline repo, you will find the training code that's already adapted for our competition dataset. And we are still developing the full evaluation code. We will release it maybe next week, very soon. The next part is about how we will evaluate your submissions. We use standard image quality metrics like PSNR or SSIM. You are probably familiar with those, but since this is an embodied world model competition, we also bring in some special robotics-focused metrics from EWM Bench. Let me give you two quick examples of what we will check. Look at the left image. We will use a dedicated model to extract the feature maps from your generated frames. This helps us analyze the scene consistency. And look at the left videos. We will track motion trajectories using a well-trained and effector detection model to evaluate how realistic the movements are. Please check out the EWM Bench paper for more details, or wait for us to release the full evaluation code. Then you can see exactly how everything works. And finally, let me share some practical advice. First, please start early. While the test server launches in middle of July, the complete dataset and the training code are already available, and the evaluation code. I think the full version of evaluation code is coming soon. This early access gives you valuable time for research and experiments. Then remember there's a weekly submission limit for the test server. So a smart approach is to fully utilize the validation set for local testing before submission. Next, the baseline EVAC model offers pre-trained weights from the complete AgiBot world dataset. That's a very large dataset. So starting with the pre-trained model for fine-tuning could significantly boost your effectiveness. Then about the data, our dataset is packed with valuable resources like observation videos, multiple action formats, camera calibrations, and more. We encourage you to fully explore the data. Next, how to represent the action condition and how to inject them into generation networks are open problems. You need to find a creative way to solve this problem. Last, some straightforward or simple data augmentation techniques are always very useful in many competitions, so you can try this. If you have any questions, you can contact us with a GitHub issue or join the Discord community or just email me. Okay, this is a truly novel and challenging task. Hope you all can have fun here.
I just want to share with you some upcoming event in this year. So yeah, see you here in Nashville next month. We will have two events. the workshop will be in the full day workshop will be at the first day of CVPR, and the full day tutorial will be on the second day of CVPR. So please feel free to join us, and also you can also join us at ICCV. We also have a full day workshop at the first day, October 19, in Hawaii. So you can come to join us. And also we have an event in WAC in Shanghai this year. We will showcase our G1 robots on site, and also you can have an interaction maybe with the robot. And also we are planning an event in Core in Seoul this year. I think the call is in September, but this workshop is still in progress. So we will notify you if we got this event done.